Hey folks, today I am picking up the EggNOGS Eggbeater antenna project. This is a kit that I built in a prior video. In that video I built all the aspects of the kit that come with it. That include assembling a common mode choke, soldering that choke to a phasing board, soldering a phasing board to the main board, adding an SMA connector, and then pulling all that together so that it fits in this PVC cap. As you can tell, we're missing something. We're missing the aerials. So that's what we're here to do today. I'm out here at the pickup truck workbench. So let's get to it. All right, let's take a quick look here at the tools and the materials I'm going to be using to create these aerials. First of all, the material. This is a galvanized steel. I'm using this simply because I have it. I do think it's going to be a great material though. It's rigid yet bendable, so my hope is that I'll be able to fabricate the shape that I need and that it's rigid enough that it'll hold that shape once I deploy it out into the weather. Here are the key tools I'll be using: some nippers, some lineman's pliers, some needle nose pliers, and a set of channel locks. I'll also be using this fiber reel, which has a kind of a cloth type tape to it. I think this will be a better fit, and I'll be able to get a more accurate measurement when I'm measuring something that's not necessarily going to lay flat for me. Those are the tools that we're going to use. Some other tools that I attempted, and you can see what I mean by attempted. I tried a lot of different techniques with different tools to try to be able to create the loops and the bends that I'll need to actually create the aerials. And some of these tools were successful, these were not. These fencing pliers are great in working with these materials, but you just can't get any accuracy or precision with them. They're almost like a hammer. These work just fine for cutting this material. These work just a little bit better. Here's a standard tape measure with a standard very rigid tape. Not great for measuring something that isn't going to lie flat. And here is a pair of pliers that's much less robust than these. I was struggling and actually starting to bend the tines on these pliers when trying to manipulate that material. So those are a no-go. But that's what we've got for tools and material. Let's get building. All right, first thing we're going to do is we're going to cut our material to length. The bottom and top are 17.1. The sides are, I believe they're 20. Let me do a double check. The sides for the 436.5 megahertz are 20.9. So if we add up all those parts and pieces, we are at 76 centimeters. So let's go ahead and cut our material at 76 centimeters. Now let's see here. So here we are, 20, so I gotta go 96. Space this out just a little bit further. $96 is going to be right here. So I've got my end nippers, and they do a fine job on this galvanized steel. Okay. Very good. Now let's see. 17.1 divided by 2. That's going to give us 8.55. So our bottom portion needs to be 8.5. And just a smidge if we want to try to work that in, which is going to be practically impossible. So we're going to say 8.5, which is going to put us right there. Let me just roll this mark around. Okay. And that's where we're going to make our first bend. So I'm going to take my nippers, I'm going to, now this is the trick here. You have to hold this fairly tight so this does not slide or move, so that you get a bend right on your mark. Okay. Okay, now we've got to make our first side bend, which is at 20.9. So let's bring this out here. So almost 21. It's 10, 20, almost 21. Okay. Just copy that around. Very good. And we'll repeat the process. Okay. Not bad. It's right in the corner, so I'll take that. Now here we're going to go for a 17.1. Yep, 17.1. Check twice, measure twice, all that stuff. So we're going to do 17. Put that right on the corner. 17. One, it's going to be right there. Okay, again, I'm going to copy that around. Good. Just right up to the edge here so I can roll it. Okay. We go right in the corner. That's where you want your mark. That looks good. Okay. Here we go again. On the side, 20.9. Okay, just almost 21. Okay. Okay, excellent. Right in the corner. And then those guys should pretty much meet in the middle, which they do. And if I measure that, that should be 17.1, right? So let's put one corner there. 17.1. Is that right? 17.1. So that felt a little long. Let's try. Let's check this here. Okay, that's 17.1. That's spot on. 17.1. So these may be, they got the smallest amount of overlap here. That's like the smallest amount. But you know what? These nippers are great at grabbing just the smallest amount. Okay. I'd say that's pretty good because we still yet have to put our loops on these. All right, so let's see. I'm going to make this loop go this direction. Okay. It looks pretty good. I'm going to make this loop go this direction. Hey, look at that. Pretty good. Okay. Let's put them on the antenna base, see how it looks. All right, so let's see here. Let's go ahead and install this. And we will see how it looks. Okay, I think that looks too bad. I need to do a little bit of straightening here. Certainly don't want to try to straighten these aerials when they're connected to the base. I need to do just a little bit of flattening here. I'll make sure these are going to set fairly flat. That looks pretty good. All right, let's try again. Yeah, that looks like it's going to stand up. Okay, and here you can see the thoughtfulness of including the second set of nuts in addition to the nuts with the nylon keepers in them, so that you can install and remove aerials as needed until you get your final aerials in place, and then you can lock them down with the lock nuts. All right, well, I'm pretty happy with that. I'm going to go ahead and build another one, and then we'll try to get this thing on the air. All right, well, here I am with both aerials installed, and not bad for attempt number one. Right, the great thing about this is you can, if you're not happy with the performance or how your aerials turn out, just build some new ones. Try different material. Try several. Make a few and see what works for you. Now you can see here, I've got just a little difference in the length between these two sets of aerials. You know, is that going to make a difference? I don't know. Is it the bend that's in this bottom corner? Kind of looks like it, right? These 90-degree bends look fairly flat here, or they don't look very flat. So if I flatten those out, that probably eliminates that gap. So I'm going to tweak on this a little bit and try to get it to a point where I feel that these are even, and then I'm going to throw some coax on it and see if I can hear any of the satellites with a 70-centimeter downlink.
All right, folks, before I throw this antenna up on a 10-foot piece of PVC, I thought it might be smart to check the SWR. I pulled out my Nano VNA. I have already calibrated it. Let's go ahead and switch over to the view and take a look at it. And the thing I'm most interested in is where these aerials cross and where they touch. They currently touch, and I'm expecting that's going to have an impact on our SWR, but let's be sure. All right, so I've got it plugged in here, and I'm showing an SWR of around 2.2 at the bottom of my sweep. And if I run it up to the other side, about 2.3. So that's not great. Let's try something. All right, I've got this piece of cardstock that came with the Nano VNA, and I'm just gonna slide it between those elements. All right, so I've just got it kind of slid in there, friction fit, if you will. And now when we take a look at the SWR, I'm around 1.415 at the top end of the sweep. And let's see, as I move this around, I'm somewhere between 1.3 and 1.7. So you can see that thing kind of bouncing around as I move it. I'm sure all the stuff that I've got going on in the shack here is contributing to that as well. But the point being, we get a much better SWR reading if we don't allow those two aerials to touch. So I'm going to pull this aerial off that goes across the top, and I'm going to add a little bit of electrical tape where those things meet, and we'll see if that gives us a better SWR. All right, I'll be right back. So here you can see my handiwork. Hopefully that will focus. But you can see what I've done here is I've added a little piece of electrical tape to the very center, and then I put a few extra wraps of electrical tape around the outside edges of that tape, almost creating some bumpers or a curb, if you will. I don't know how likely it is that those elements or aerials are going to slide around a little bit, but that'll help keep it in place, I think, if that does tend to happen. All right, well, let's plug it back in and see if our handiwork actually bears the fruit that we expect. All right, so here we go. And yes, I can see that right now I am bouncing somewhere between 1.6. If I move this stuff around, I've even seen it go down to 1.3. I've got to be careful not to touch my mic stand here. I think this is good enough to throw in the air and see what happens. Well, folks, as I was running downstairs to head outside and throw this thing in the air, the sky opened up and we started to get some rain. So if you're getting rain in Texas this time of year, you just can't even complain about it. So I'm not going to. Here's what I did do, though, is I went ahead and added some tape to the second radiating element, or the second aerial here, just to give each of them a bumper in both directions in case these things tend to slide or start to slide due to weather or wind. So we're in good shape there. I thought I would also just give you guys a couple of close-up views. Let me pull up this camera. Some close-up views so you guys can see some of the detail around the posts themselves, how the aerials connect to the posts, and this little bit of a tape job that I've done as well. So let me go ahead and pull this up. All right, folks. So with the rain delay, I'm going to go ahead and call this one. We're going to bring this video to a close, and we'll have at least one more video in this series. I expect we may have two. I have a short-term plan for this antenna, and then I have more of a long-term plan that I hope you guys will find interesting. So in the next video, we will test this and make sure that we can hear the downlink on some satellites. And in the subsequent video, I should have the 2-meter version of this antenna completed at that point. And I will show you what my plans are for the regular use of these antennas. So thanks for following along, folks. If this is something you enjoy, consider subscribing. Please hit that like, hit the notification bell, all of those things. It really does help, and it lets me know you guys enjoy this. So thanks so much for coming along with me on this journey, and I hope to see you on the next one. Until then, 7-3.